All right. So that means if the external signal given to the muscle should work, right? Have you ever seen a six-pack simulator? So they place an electrical signal, the muscle swing. How many of you have heard about pacemaker? Put it to the heart to give a shock to your heart to swing. So that means if you give an external signal, the muscle swings. So that's how when you get an electrical shock, the muscle don't know what to do. So the heart stops, right? It don't know what to do, so it stops. So that's how it works, right? So for example, let's say, let's say like yeah, but the voice is coming from somewhere there. Okay. Yeah. Can you? Hello? Hello? Not from my. It's from there. Okay. So now let's see. So you go to a classroom and you see your teacher and you say, "Hi, good morning, teacher." Right? So these decision. Yeah. So decisions are made from the input from the brain, right? So you see, then the vision signal go to your brain in the background, right? The optical signals are processed at the background. So then after that, it's a teacher, and your frontal lobe decides to say good morning. So the decisions are made from your frontal lobe. So this is how the brain works. So now, as I showed you in the beginning, the blue color neurons interconnected to make the decision. If you break into very close view, so this is how a neuron looks like. That's so. No. In the animation, it looks like, but in real life, we can represent the neuron in this now. Right? This is a biological neuron. If you see, there is a small part over here. This part is known as nucleus. Okay. So there are small parts over here. So these part are known as dendrites. Okay. So these are known as dendrites of the human brain, and this is known as the nucleus, and this one is an axon, and these are synapses, right? So if you go back and see what are the actions, actually the dendrite is the place where the neuron receives the input. So it can be from my eyes as a sensor input or from one neuron to other neuron, because 83 billion neurons are interconnected. So one output from one neuron goes to another neuron input. So these are the dendrites which receives those inputs to a particular neuron. Okay, so it can be from a sensor, or maybe our eyes, skin, or nose, or else from another neuron. And this is a nucleus. Nucleus is the part actually which makes the decision, right? So one neuron decision. Okay, axon is the part of the neuron which communicates the output to the next neuron, right? And this is the part which is going to communicate with the next. So this part will be connected to another neuron, this part, dendrite, right? So that is the synapses output, which is going to connect to the dendrite input. So this is the basically the human brain architecture, neuron architecture. So the scientists studied this stuff. They mathematical initial stage of artificial intelligence. So if you design this, it's getting an input, making some decisions over here, and communicating through a certain path, and this is the to the other neuron then. So this is the concept of a neuron, right? So now this is one neuron. So if you take a brain, 83 billion neurons are interconnected. So one output connected to another neuron, this output connected. This is this, like 83 billion. So how many of you heard there were two GPT versions, ChatGPT. ChatGPT 3.5 is the publicly released one, and the ChatGPT 4. So they say 70 billion parameters, 175 billion parameters. What do you mean by that? So we are going to come to that. Okay. So now this is the optical lobe that saw your teacher, and that the frontal lobe which decided to say a mark. So now you got the concept, right? How the neurons work, because it is very important. Understand how the mathematical model of a neuron is going to work. So let's play a small video and see how this is an animation video. So you can see how these neurons are going to communicate. Yes? I'll play this in this.
Sounds. Settings. Yeah. Let's see. That's it. Yeah. That's it. No. You use the body there in your laptop. It will be reduced. Yes. Yeah. You can play from your computer. It can be here.
Okay, let's see whether the volume can be heard, or I'll explain what is going on. Okay, so basically these are the neurons. Okay, so these are the neurons connected to the body. So you know how the decisions are made through small electrical signals. So if you see, this is the axon which communicates the output to the other neuron. So if you see here, this output is going to the other neuron. This is the part we call this as a synapse, right? So this is the synapse. The synapses are not connected as shown. There is a small gap like this, okay? So when you do something, so this is how the synapses are connected through a small electron potential, right? So what will happen is, for example, you go to a cricket practice, you want to play a cover drive, right? Let's say cover drive. So then you learn the cover drive first time. It's not happening in a proper way. Then you learn second time for a week. Your coach coaching you maybe for a month. After that, finally you will be able to play a cover drive. So what is happening in the human brain is you start to learn. So that means the brain tries to learn something through the neuron connection, where the synapses strength, this strength is at the beginning is very less. between the interconnected neurons, right? So you are learning something new. So it need to memorize. So second time you are learning, third time, fourth time. Time by time, when you learn again and again, strength between these two become very strong, right? So that means after that, when you see a ball for a camera, you can simply play that one. So if you, another example, if I want to say, like you be with a person for a day, so you may, I might see you in the public in maybe in some other days. Sometime I may not recognize you because the first time I'm seeing you, my brain try to memorize, and there is a small connection made between the neurons synapses through my synapses. But later on, it's not that strong, so it will be like that. But when I see you outside tomorrow or day after, I might recognize or may not recognize. I'm not sure because my synapses strength are not that strong now. But if we go for the second week, third week, fourth week, your brain, the image of your face and everything is strongly connected to me. So that means the strength of the synapses will become very strong. So then even if I see you in the far away, I can say hi. I will say hi because my brain memorized me. So that is the things happen in the brain while we are doing. Okay. So do you think this part AI? So when it started, any idea? Is it in 2001? Maybe 2010? 14? 21? It started way back in 1950s. 1950s, right? So there was a conference called Dartmouth, which held in 1956. So a couple of experts came. This is right after the World War. So everyone is thinking about, we have made machines which can do a lot of activities, right? We can do for production, which can do for, we fought in with the World War and everything. But all the machines are operated by humans, right? So they discussed, what if we make a machine which can think and perform like a human? That's the topic that they had taught, right? So that is the artificial intelligence. The first word used. Okay, we should create an artificial intelligence which can control machines. That was the topic in 1956. These gentlemen have discussed. Okay, so this is the plaque which was embedded into that, and it started in 2000, opened in 2016. Remember of that Dartmouth conference. But they didn't talk anything else. They don't know how to do, they don't know how to design a neuron, nothing. At that point, they have zero clue. But they talked about it. Okay, now we have machines, all are controlled by humans. Why we can't create a artificial intelligence to control these machines? So we got together in a bar and we talk a lot of ideas. Similarly, about this idea, now we are paid for it. All right. So now let's break down these areas into certain sections. 1943, the mathematical model of neuron, they didn't finalize. They started in field, right? In 1958, the single layer perception model. So that is, we will learn what does that mean today in our thing. Then 1986, back propagation. We will learn what is that mean. 89, convolutional neural network. This is a huge change that we are using. CNN, convolutional neural network. 1990, recurrent neural network. 2006, deep learning. So these are the things up to 2006. If I put another layer, 2017, transformer architecture, right? And 2022, ChatGPT, right? So these are the breakthrough that happened in the past. Okay, so no worries. What is these words means? We are going to cover everything. Maybe up to this one today. Rest of the thing in upcoming lecture. Okay. So now let's break the design the mathematical neuron together. So now we know if you take a single this neuron, we have a dendrite, which we defined it as an input. We have a nucleus, which we defined it as a processing unit, no decision making. We have an axon, which is the output, and we have synapses, which communicates with the other neuron input. Right? So these are the major part of the neuron. Let's see now how we can define these things mathematically. So, and also, as I told earlier, these are other neurons. These neurons are communicating with another neuron. That's how the neuron network is, human neural network is interconnected, right? So neurons and this output is connecting to this input. How? This is the mathematical neuron. Wait for that part. Please pay attention because this is the starting point. If you don't understand, it's very hard to catch up other stuff. It's not a huge mathematics. If you know addition, multiplication, subtraction, that's all needed for mathematical doing. Nothing else. No differentiation, no integration, nothing. So we have dendrites which gives the input to your neuron. Here also we have inputs. These x1, x2, x3 are the inputs of a mathematical neuron. That means which are equal to the dendrites in our human neuron. And we have a function here. This function what is the nucleus of our mathematical neuron. And we have an output, y. This is the axon of the human neuron. And we have W1, W2, W3. These are weights. These are weights. What is missing? We had inputs, we have outputs, we have nucleus. So what is the missing part in the human? No. Synapses. The synapses are the weights. So as I said, the synapses is the only part when we learn something which is going to change. Initially, the strength between two neurons get weaker. When you play the cover drive again and again and again, it becomes strong. Strong. You can play the cover drive without any effort. Right? So that's the thing. So another thing, if it's become very strong, I can see you from far away and I can recognize. So this is, for example, our example. How, like most of you might have kids in home, right? Or you have seen kids in your home. Can you see how they learn? That is the interesting part to understand how the human brain learns. So you show an apple to a kid and say, this is an apple. Do you think the kid will say, that's an apple? No way. So if past second day, what is this? He won't even care. She doesn't remember that. Because the neurons are not strongly connected. Second day you say, this is an apple. Third day you train. Fourth day, fifth day, maybe after a week, say that's an apple. Right? You might remember that is an apple. That's a doubt also. But again, this is an apple. You showed red color. But you forgot to show green color. Then, if you show the green color apple, not red one. Because the kid doesn't learn. The synapses strength are not strongly made to make. So later on, you train on the green color one. Then the kid knows there's a red apple and the green apple. Then he says that's an apple. So weeks after, when you go to a supermarket, the kid will simply identify that's an apple. That's a correct, right? Based on the learning. So this is how the human brain learns. So how we train the human brain? By showing the inputs here and there, different apple images, right? Different color images of an apple. And we say this is an apple. So those are the inputs that we are giving to the human. So the output to recognize that's as an apple, the kid. Function in the neuron, something happening in the human brain to understand or do that thing. But what we are, by training that kid, what we are making is, we are changing the synapses strength. That means in the mathematical model of a neuron also, these are the changeable parameters, right? While the mathematical model learns, these are the changeable parameters. Clear? So now this is a single neuron, which has an input, dendrites, it has an output axon, this has a function, which is nucleus, and we have this. So that is, what is this function? Okay, nothing. X1 into W1 plus X2 into W2, input multiplied by the weight. X3 into W3 is going to be the input, and there is a bias. We give it somewhere here, which is called B. is a constant, right? It's called bias, right? So now tell me, earlier we told server ChatGPT 3.5 had 30 billion parameters and ChatGPT 4 has 175 billion something parameters. And there are some other GPTs available, which are 350 billion parameters. What do they really mean by parameters? I think W1, W2, W3 Greeks weights and these biases are called as parameters, right? Now you can imagine 83 billion parameters mean how many mathematical neurons should be connected to make large neural network to have 83 billions of weights and biases, right? So that is equal to a human brain, 83 billion neurons. So neurons, not the parameter. But here still we are not developed a mathematical neural network equal to a human brain. But in the future it will come up. 83 billion neurons into multiple synapses. Right? That means these weights. Then the AI is going to outperform human. So it's not far away. But still, we are on the edge of that thing. There are certain limitations. We will discuss those things on the way. So now, this is a mathematical neuron. Calculate the output. Right? What is the output? What? Can you just quickly do a calculation? If you have a pen and paper, or else just x is 0.2, x2 is 0.1, x3 is 0.3. So these are the inputs. W1 is the weights, we call it weights, 0.5. W2 is 0.2, W3 is 0.8. And what is the output one? There is no biases given. Bias means it's a constant. We'll come to that point little later. Why? Only the inputs and the weights are given. So the bias is 0. So just substitute it, you will find the answer. X1 into W1, X2 into W2, X3 into W3. That's all. Just the multiplication and addition. So you will see these kind of animation because this course is designed for overall about kids. So sometimes it might be childish, but the kids like that. And that, it's simple. So you will find it 0.5 into 2 minus 2, 0.2 into 0.1 plus 0.8 into 0.3. So the y is equal to 0.32. So that is the output. So this is how the output is given. So now this output is a single neuron output. But in the neural network layer, this will be given as an input to another neuron, right? You get it? So multiple neurons are connected. So this is a single mathematical neuron. But we can't do anything with this single mathematical neuron rather than doing a small curve fitting, right? So now we come to the artificial neural network. So we have seen a neuron, and that is single neuron. So artificial neural network means basically we are going to have multiple inputs, right? And we are going to have multiple outputs. There we had only one output. Here we are going to have multiple outputs. In the middle, we are going to have interconnected neurons. So this is input This input side is called as input layer. Input, that is output. So we call those neurons as output layer neurons or output layer. In between, there are multiple neurons. We will keep that as a neuron, okay? Neuron. So these neuron layers are known as hidden layers. So if you take any neural network, we have input layer, output layer, and hidden layer. So these hidden layers are interconnected like this. Okay? So this input gets it, output is communicated to all the neurons, right? So the output determined from this neuron is communicated with all the neurons. Output that you have determined, let's say this is a single neuron that you have calculated now. Why? That is going to be communicated with all the neurons. Now, here it's going to go through all the neurons. So output, you will get the output finally. So this is a simple neural network, right? Simple neural network. If you calculate even, not even, you will find how many weights? 1, 2, 3, 4, 5 weights per one neuron. Like that, if you calculate how many connections are there, and let's say each neuron have a bias, you will not exceed 150 or 100 in this neuron. Then imagine 83 billion parameters of a ChatGPT. How big it is, right? How big it is. So now these are the weights. These are the weights, right? These are the weights. The input, output, multiply by the weights and go to the function. The function calculate the output and give it to you. So that's how these input of a neuron calculates the function. That function output is communicated to the other neuron. So these are the parameters. When they talk about parameters, this is what they mean. The biases and weights, right? So now if you go there, they are saying Facebook released a 7 billion model called Code Llama. Llama. Have you heard about that? A camel looking face looking ChatGPT equivalent Llama. So everyone is trying to build up neural network because ChatGPT got the whole market. After that, other big giant companies, they don't know what to do. They are left over. So they are trying to make certain neural networks to make similar models as ChatGPT. So they increase the parameter and they improve the efficiency or reduce the parameter and say my size is less, but my accuracy is high. Something like that, right? When the parameters are high, definitely the storage space is also going to be high. If you write, we want to store 10 mobile numbers in a phone or 100,000 mobile number on a phone, the storage space is different. Similarly, the number of parameter increases, the size model also increases. So that happens in the ChatGPT, right? So Para said I'm working with one professor called Professor Jason Marks. He is from US. He is one of the consultants for this ChatGPT. He works with ChatGPT as a consultant. Okay. So we are going to now make a model. Now there are 83 billion parameter models in ChatGPT. ChatGPT is capable of answering any question. Sometimes those are wrong. Right? If you ask about law, yeah, it knows law. If you ask about some science question, it knows science question. But we are not sure whether it's correct or not because they train in a different all the data. They didn't analyze this is a true data or false data. But let's say I need a model which I don't want actually the GPT to know about everything. I need a model. So I'm a lawyer, let's say. I want a model when I ask law related question to ChatGPT, it should answer 100% correctly. But I don't want to connect to the ChatGPT server and expose my question to the ChatGPT. I want to save and secure my data with me. So that means the only way you keep your ChatGPT in your machine. And you keep it ChatGPT in your machine, no way, it's huge. So what we are trying to do is we are cutting these weights and optimizing these weights, bringing the model to a very small size, 3 GB, 6 GB size. Then you can put it in your machine and you can run it. But that model is only capable of answering that law. Or if I fine tune that model for Python programmers, it will be able to answer only Python program. So the concept is going on. So we'll discuss more about that in detail when it's coming up. So now everyone knows what the ChatGPT parameters are. These weights and biases. Clear? So now, small exercise. This is a small neural network. One input. These are the weights connected. Second layer, one hidden layer, and one output layer. One input layer, one hidden layer, and one output layer. But in practical, there will be thousands, maybe 100,000 of hidden layers connected. Right? Now find the output layer. So let's not do that. It's everyone knows mathematics, so just forget about it. So this is now if I take x1, x1 is going to be multiplied by 0.5, and x2 into multiplied by 0.4. X3 is going to be multiplied by minus 0.3. That is the output going to be from y1. Let's say that y1 is, let's say, some value here, and we can go to that answers. Yeah. So then y1 is going to be 6.4 when you calculate. Okay, you can do the calculation later. So now this 6.4 is going to be multiplied by 0.1, and 6.4 is going to multiply by 0.2. And these are the output is going, for example, the O1 if I want to calculate, y1 is 6.4, 6.4 into 0.1, y2 is 2 based on the calculation, 2 into minus 0.3, and y3 is 4.6, 4.6 into 0.2. That is going to be the output. Now output is a number. A number is a do that once. How do you do that? That's the meaning number. So all these words are not to a number. So we will come to that. Okay. So we learn how to build a small chatbot using ChatGPT. Okay. So we learn those stuff. Those are not hard. Seems to be hard, but when you just look in, it's now very easy to do stuff. Okay. So no words. And this is the way that you are working. So now you put the input, and based on these things, these are calculated. Based on these values, these are calculated. Finally, you get the output. This is simple neural network. So if you take a 83 billion parameter neural network, multiply, finally, right? So how long it will take? Manually, we can't do that. Mathematically, if you compute that thing, even the so you need to calculate, multiply 83 billion parameters to get the output, right? So, but it's very quick in a GPU. How many of you know? CPU, how many of you know? Everyone knows, right? Every computer has a CPU. GPU came after around, like, become popular after 2010 because of the NVIDIA. GPU means CPU, GPU difference. If I want to say it in a very small way, don't tell it to anyone because that's not the truth. To make it understand, okay? If I say, like, okay, I need to add 1 plus 1, 2 plus 2, 3 plus 3, 4 plus 4. Let's say these are the numbers I'm going to add. If you take the CPU, what it will do is, first it will take this sum and add that to 2. Then after finishing this, it will come to this and 4. And this come to this and output 6. Something like that, one by one it will do. There are certain parallel processing elements also, but this is the way of functioning of a CPU. But if it's a GPU, it will load all the things at the same time and give the answer. So that is the way the GPU works. Graphical processing unit, right? GPU. So that gives quick one shot answer at the same time. All the answers are given at the short one time. But CPU, one by one. So that is slow, right? So that's why, even though the 1956 the AI started, after 2012 only, the use of AI started coming because of the introduction of these GPUs, right? With the CPU, you say, hey Siri, and you have to go make a play, come back and say, you say, hi, how can I help you? With CPU, right? It's very slow power. But with GPU, all these things are multiplied together in such a way, output is given at the next second, right? So that's how the AI evolved. So why the ChatGPT took 1956 to 2022? It's not didn't take that much of time. It's actually took 2012 to Now NVIDIA is releasing a lot of GPU with multiple parallel processing power, right? So even a small Jetson Nano board can handle a robot with voice. You can do all the things that you are doing with the parallel processing power. So that's the power of a GPU. Okay. And so now you can understand CPU, AI will be slow. GPU, the AI will be very fast. So now you might have a question. How many of your laptop have GPU? Maybe not, right? Most of the people don't care about the GPU. Internal will that VGA card only the part, that's a very small part of that. So other than that, nothing. That's why in our platform we have integrated the platform which has the GPU. So it's free for a certain limit. So we can use that platform to code AI related activity. But if you try to do it in your machine without a GPU, then you put for the like certain activities, let's say training, we'll see what is that now. When you go for a market shopping, come night, still certain part of the thing is free. Right? So, but the GPU is very fast. We'll see the difference, okay, while we are doing. So, all right. So this is about the neural network. Then after that, the final answer you can calculate. It's not a rocket science, you can do that. Right? So now, concept of training and build. How these things happen in the human brain. I've seen how the kid learns, how the kid learn about anatomy. Right? So now we will take another example, the driving school. So how many of you went to the driving school? Right? And so you might have experienced this thing. Okay, when you learn driving, you need to handle the steering, accelerator, maybe it is a manual, it's a gear. The brake, accelerator, handle and the gearbox. So all things are the things you have to control through your brain. So what do you see while driving? The vision, the horn sound, and the art of reading the driver blaming you, the bad words, all are the things that we hear from the environment, right? So based on these environmental inputs, you have to make these decisions. So can you do it just get into a car the first time? Okay, I'm going to drive, can you do that? You can't do it. There should be a certain training process your brain should go through. Either you look at a person who drives and you learn from him, or you go to a driving school and learn from him. Right? Anywhere your brain to go through a learning process. So let's say these are the activities that you have to accelerate, steering, brake. You say it's auto driving car, nobody uses auto driving nowadays. So the gearbox is fresh from this level. And it's in Dubai, very rarely we would have manual cars. Do they have manual gear cars for Dubai? Yeah, but I don't know. We took the example of a gearbox. So only these, let's say we are going to handle these three operations. So now we will see the first learning time. Okay. So all of you have started the car and you are going to accelerate. Your supervisor say slowly. Well, if you have a gearbox, okay, that's the hardest part, right? Release the clutch and press the accelerator. I had a hard time on that one. So, but nowadays it's easy. Just break that and you just press the accelerator. So now your supervisor say, okay, press the accelerator very slowly and you clear slowly leave that thing. But if you are wearing a manual gearbox car, when you leave the clutch, then the car will stop. This happened 100 times to me when I'm here. Right? That means my brain didn't understand how to do that. But later on with the practice, I was able to smoothly release and press the accelerator. So now you listen what the instructor says and you say, look, stop, there's a stop sign. Stop. Slowly stop. Right? Okay, there's a right turn you have to take. First you have to stop and see the vehicles are coming or not and take the right turn to the curb, close to the curb. So these are the instructions the driving instructor gives you and you learn from that. Right? So this is kind of a supervised learning, right? The supervisor is there and you are learning, he is supervising you. As supervised learning in the human life. Can also have a supervised learning. Because it's a human brain, we learn only in a mathematical way. Whatever the human brain should go through for the learning process, that mathematical model also should go. You think the human are very smart? No, if you take any invention in the world, all are inspired by the nature. We look produce something copy paste. That's how. Even the solar panel from the leaves, how the leaves make energy out of sunlight. So that's the inspiration. They studied how to make, came up with mathematical material models. Now we are using solar panel. That's how everything is, right? So they also studied how the human brain works. It's through supervised learning, one thing. And the second thing is reinforcement learning, right? So that means now you learn something, now you are driving, right? While driving, you made a mistake, right? Then traffic police stopped you, you were run over. So that means that is a penalty. That is a penalty. So then you know next time, if I do it, I will get another one, right? You learn from your experience, mistake, right? And if you drive very nicely, maybe a passenger sitting in the back side saying, yeah, that's a very nice drive. So that means you know that is a credit to you. Based on the credits given to you, based on the data that are provided to you, that is the error or the penalties provided to you. You learn by yourself. Next time when you go, you know that point I cannot overtake because last time I got a ticket. So you will be very cross the yellow line without overtaking, right? Another way. So that's how you learn. That is called as reinforcement learning. Other thing is known as unsupervised. Unsupervised learning means you took the driving test and you took the license, then now you are driving. But now you are going from Colombo to some other area, maybe Morocco area. Right? Have you gone to Morocco area driving in a car? If you three times over there, you just leave it, right? Don't do that. Don't go over and negotiate. You stop the vehicle in the middle and come and get it. Right? So these are unsupervised learning. You took that thing and you are going into a new area. You see certain traffic patterns, certain drivers drive different. You are start to identify these things. And you automatically find out, okay, this is not a safe area to drive 70 miles per hour or kilometer per hour. Let me reduce my speed, put into this. So these are unsupervised learning based on the human that nature that you are learning. Learning that we are going to make the neural network learn. What are those? Supervised learning, reinforcement learning, and unsupervised learning. So in the ChatGPT, when you go there, when you type some questions, it gives an answer. At the bottom, there's a thumbs up mark, thumbs down mark, right? How many of you have noticed? Today, go and check that GPT query. The answer is provided, thumbs up, thumbs down. If you thumbs up, it goes as a reward to the ChatGPT. That means it's a reinforcement learning based model. If you give down, then the ChatGPT learns from that, right? So these are the things. So that is human is giving the feedback. That is reinforcement learning, right? Okay. Unsupervised, unsupervised, we will go through that in next classes. So now these are the training process. You give the input. So now, first what will happen is, there will be a, you can see the weights are changing here. Then the error calculation. How the training happens. Let me explain what is happening here. Now you are giving a input, right? Let's say the supervised learning problem. You want to make, to detect the cat and dog. Let's say you are going to make the neural network to identify this is a cat or this is a dog. Very simple example. We can say that this is a cat, this is a dog, but how the neural network knows this is a cat or this is. What we do is, okay, we are going to train. We are going to give the inputs, images of a cat and dogs. So as I told you, for the kid, what we do, this is apple, this is apple, this is apple, this is orange, this is orange. Like that, we showed multiple images of oranges. Not only one orange and the kid doesn't learn. Similarly, we need to give multiple dog images, not one dog. You have to teach multiple breed of dogs, multiple breed of cats. So imagine you take those cats images, dog images. So these are the inputs that you are going to give. We learn how to give those images as an input in a separate place. Okay. Now imagine you are giving the inputs, those are the images. So what will happen is at the first stage, randomly the weights are start. As I start with some random numbers, right? So now I give the input. Based on the input, this multiplication happens. This find the value. Finally, this multiply. Let's say if we set a dog, this will be higher value. If we set a cat, this will be higher value. That's how the numbers, we are working with numbers. So now what will happen is when you put the dog in it, and you label it as this is a dog. That means you are supervising. You are not just giving the dog image and you don't say dog image and you label the dog image as dog. Cat image, you label the dog cat image as cat. That means the neural network knows it put the dog image down and it's multiply. Finally, it calculates what's the value is going to be here. If the value is less over here, this should be the dog, right? If is it dog, this value should be higher. If is it cat, this value should be higher. That's how the neural network is made. So now this should be higher, but when you put the dog image with this multiplication, this becomes low. That means that is wrong. So now we have to calculate the error. This should be 1. If you see the dog, this should be 1. Right? 1 is the maximum value in the probability, or 100%. 1. But what the value I got is earlier. What is the value I got is something around 0.64. Then what I do is I calculate 1 minus 0.64. So that is the error. So I say there is an error. It should be 1. But I am getting 0.64. Then I get that error back to the same input saying there is an error. So that is called back propagation. I train the network, calculate the error, and let the neural network know there is an error. Then what happens? The neural network, in such a way, change these weights. Change these weights. That 1 is just a number, but how we get that 1? Multiplication of these weights, right? And it changes the weight. Then second time, you put the dog, then it's dog, it's calculated. Finally, certain value 0.8. Error got reduced, right? Then, but still the error is there. Then you say the neural network, no, still I have an error. Then third image, dog image. Then you calculate, right? And you get 1. But again, cat image. Sometimes you will not get 1 over here. Cat dog, you train, you multiply, change these weights again and again. Where the error will be very less. In AI, error is very, say, there is no probability for 0 error. Therefore, the AI is a probabilistic model. It will not say, this is dog. It will say, this is 95% sure. Right? So it will not say, this is cat. It may say 80% cat. Even if you unlock your phone through your face, it's not recognize your face 100% slowly. No, it's recognize my face as 85% slowly. But they put the threshold in the programming. If the decision is more than 75, is the truth. Right? So that's how it's going to happen, the training process. Now you get it, right? So you give an image, change these values, and get the output. Calculate the error because you know what should be the output is. Right? This should be 1 for the dog. This should be 1 for the cat. Then you calculate the error, come back and say, okay, there is an error. Then the neural network change these parameters, get the output. So this is how the training. So now I'm putting a 1 dog image, changing the weights, calculating this, getting the error from that. This is called as, like, and let's say we have 5 dog images, 5 cat images for the training. So the second dog image, the weights are not changed. I go there, calculate the error, come back. Third cat dog image, do the same, come back. And cat image, do the error, come back. And I collectively select all the errors and I give it to the neural network saying, in this training process, this is the error. For all the 10 images, 5 images, right? Then I feed it in the neural network in such a way, okay, this is there. Then second time, I'm going to teach the same images. First batch, dog, come. By the second training, these weights are changed because based on the error that I did. Second, I'm going to use these 5 images, going, calculate the error, second image, third image, fourth image, up to 10 image, calculate the error, come back. And this time the error will be lesser than the previous, right? Because it knows. Then randomly, in a such a way, these weights are changed, right? Then I calculate the third set. So what I am doing? Basically, I am showing this is an apple, this is an apple, this is an apple to the kid. I am showing you the thing, right? I am showing you the neural network. So this is known as training cycle. Training cycle. In other words, we also call it as epochs. Now, training cycle or epochs. E-P-O-C-H. Epochs. So if you say how many epochs you run the neural network, that is means the training cycle. How many training cycles? If I stop the training cycle at third for this image classification, let's say I stop at when it's 0.575, when the error is 0.25, I say, okay, this accuracy is enough, I stop. Then at a point, my accuracy will be 0.75, 75%, right? With 3. But if I run more training cycle, I might have a chance to improve it to 90, maybe 95. Even after 95, do you think I can go to 100? No. At a certain point, this weight changes happen, it will not affect the output. So it is stuck at a point. So after even a certain point, when you go training cycle, it will be accuracy will not improve. So we are going to see this stuff in a couple of lectures. Let's take an example. Yeah. Yes, yes. So we are not going to deal with this number, right? In the Python program, there are ways. If you want to multiply a neural network, okay, 1 by 1 plus 2, a plus b, you can't do it like that. So these are automatically assigned through the library. So in the Python program, we call a library which handle these ways. Right? So we are not going to code a plus b plus c. No, that means you can imagine you can code within this line. So it's already there. So we are just going to call that function. It will take care of these weight changes and everything and execute that. And now we'll take a small example. This is an electric circuit, right? So we have a circuit here, resistor. But so you know there is an internal resistance in the battery. How many of you know there is an internal resistance in the battery? So when you connect a small LED bulb to a small battery, it lights up. But if you like, okay, let's put it in this way. So how many 1.5 voltage battery, right? So what is the voltage of a car battery? 12 volt. 12 volt. So if I ask you, I connect 1.58 batteries, 1.5, 1.5 in a series. If I connect to a car, will it start? Why? Because of this internal resistance. When the current goes high, because the car starting current is very high, the lithium ion battery or the lead acid battery that we are using in the cars to start are very less internal resistance. When the current goes high, the voltage across, the possible voltage that we can get from this will go down, right? Because current goes high means I into R is going to be here. So the voltage, possible voltage will go down. So you cannot get the desired current to start the charge. So that is the internal resistance term. We break it into this. So IC is the circuit current, VT is the battery terminal voltage, internal resistance is an open circuit voltage. Okay. So open circuit voltage means this wire is not connected. You are just measuring the voltage across this. Right? R is the internal resistance, IC is the current, RL is the load. Load can be anything. So this is a simple circuit we have learned in A level numbers. So now from the current load, we know if you take the VT is going to be equal to E. This is E. Let's say this is E. Sorry, this is E into minus R into IC. Minus R into IC. So this is battery terminal voltage. So VT is going to be this one. So this is going to be E is the rated voltage, actually. This one. E minus I into R. Right? The voltage across this one should be E minus I into R. So that's what I have added over here, right? So what we do is to calculate the internal resistance of a battery as a practical. So we do change the current and we calculate the VT and we determine the resistance, right? So that's the typical way. I think A-level physics we have done certain practical, I remember. So now if you see, when the current goes high, the terminal voltage is only go low. So that is the reason we cannot connect 8 pentose batteries to start a car. Because when the I goes high, the terminal voltage will be very low. So the car will not get the desired current and the voltage, right? So that's the main reason. So if we break it into it. So now what we have done is, in the physics lab, we change the current. So change the current means what? Basically we change the load. We change the load to get the current 0. So that means it's open circuit. The VT is 9. If there is no current, VT means that you know the E is 9, right? No current, I into R, this is 0. So VT is going to be 9 volt. That is the open circuit voltage. Then you calculate 1 ampere. So what is that? VT. You change the load, get 2 amperes, and you calculate the VT. So you change the current and you have calculated the VT. So this is a practical example. Now, if you know how to calculate the internal resistance, you can do, right? You plot this curve and you get the curve. The slope of that curve is going to be the internal resistance. Can even say this is the thing that VT is equal to minus R into IC plus C. This is the equation that we have seen in the last lecture. It is equal to Y is equal to MX plus C. So if you plot these points in the XY axis, right? XY axis, and in the XY axis like this is IC and this is VT, right? Like this. And if you plot a straight line, this is going to be Y is equal to MX plus C. This M is the internal resistance, right? So simple. So now how to do this with air? A small neural network. So this will be a solid answer if you do that. Let's use the AI to do this, right? So now we will design. So R is going to be the minus M. So if we design, right? To that. So where we are going to give the input current. Okay? And we need an output layer as well for the neural network. Is going to be the VT, right? Input is going to be IC, output is going to be VT, and we have to, our task is to calculate the internal resistance. So then we will add one neuron in the middle, which is a hidden neuron. So this is the neural network architecture that we need to construct a neural network to determine the internal resistance. A very simple example, right? One input layer, one output layer, one hidden layer. So how the layers are connected in between? Using the weights. So there is a weight connecting this one. There is a weight connecting this one. That is W2. This is W1. And this is the neural network. And also, we should have a bias, right? We should have a bias. In the previous example, we eliminated because it's going to be little complicated. So we have a bias also in the input neural. This is a simple neural architecture for this particular problem. Okay, now we are going to see. First, okay, first we will calculate. Okay. What is the input to this neuron? So that is going to be IC2 W1 is going to go into this neuron, right? IC into W1 is going to go to this neuron, right? Then what is the output of this neuron? That is going to be IC into W1 plus B is going to go to the output. So now that output is multiplied by W2, right? That output is going to be multiplied by W2. So now if you do that, IC into W1 plus B whole into W2 is equal to V. Am I right? So now VT is equal to W1, W2 into IC, B into W2. Right? Is this equation correct? Yeah. So now if you take this one, this is more or less equal to mx plus c. Right? Mx plus c. So it's a form of a straight line. So somebody can ask why we want to have this one. Only why can't we have one neuron? Just to have illustrate you an input neuron and an output neuron and a hidden neuron. I arrange this neuron network in this way. Actually, you don't want this one at all. Right? You don't want this one at all. You can directly give the I to this one. So then it's going to be I plus B into W. Right? It can be arranged in such a way the bias can be given here. This B can be given here. So forget about that. The same problem, we can build different type of neuron. So the face recognition in normal Samsung phone works completely different architecture than the Apple. And we can play with that. We are going to do a certain task, and you are going to do a separate neural network to improve the efficiency. Okay, in home. So that kind of practice is very good. So now this is the y is equal to mx plus c. So now as a neural network, what we have? We have these are the inputs that we have, input and output. Right? Input and output. When I put 0, I expect an output 9. When I put 1, I expect an output 8.7. So based on this, I need the W1, W2, B to be changed. W1, W2 and the B to be changed every cycle. So now first training cycle, what is going to happen is I'm going to put 0, 9, 1, 8.7. I'm expecting, but I'm not getting this one. So I calculate the error and I go to input the 1. I'm calculating the error. Expected value is 8.7, but actual value is something else. I calculate the error. Input I am putting 2. Actual value I expect is 8.6, but I'm not getting 8.6. I'm calculating the error. Like that, I calculate. So this is one training cycle. Then I backpropagate the error to the neural network saying this much error you had in this training cycle. Then all weights randomly changes, W1 and W2 and B changes. Then the second training cycle starts. So I set 0 and there is a value, but I know 9 is expected value, calculate the error. Second training cycle, calculate the total error. Come back. Third training cycle, fourth training cycle. Finally, I will stop at a point when I get the actual answer. But in AI, it's very rare. You will get, when you put 0, you will get 9. When you put 1, you will get 8.7. No. You will get 8.999, maybe 8.679, something like that, right? So very close value. We cannot get. So now, what is going to happen here? This is the way the AI learns. I'm going to show an animation. See, every time the training happens, this is the straight line, the weights are changing, and the error is going down, and this line is approaching the blue line. You see? So I started at a certain point, somewhere here. You can see the weight changes here. W1, W2, B into W2. Changing. Every cycle, the error is going down. Right? So now, from far away, I am getting the line very close to the blue line. So now I am getting the most fitted line. So this is how AI works. In mathematics, you go and plot the line, find the least square error, and you determine the straight line. That is a straightforward answer. That is a correct answer, 100% correct answer. But in AI, you don't do that. The AI learns in such a way, changing the W1, W2, calculating the error, give it to the thing. Okay, it changes the weight and changes the shape a little bit, straight line, and it will goes. And you can stop at a point. Even like I stopped at it's going 70, 80 training cycles. You see here, 80 training cycles. It started somewhere around 0.042 the error, total error, and it's going down for each cycle. When the error is going down, error value is lesser, going lesser and lesser, the line is approaching the zero. So what is happening? W1, W2 is changing in such a way to reduce error. Then it again changes, error reduces, again changes, trying to optimize. See, after a certain point, the change of error is flattening down. So therefore, the changes over here also not much happening. Right? So now you decide to stop at 100 points, airports. Then you stop and you say that is the estimated curve for that. Right? You don't say this is the curve. This is the estimated curve. So that's how in the probabilistic way. Clear, right? How this curve fitting is done through here. Yeah, cool. So now we are calculating the error. How the error is calculated. Okay. Now this is the equation we got from the neural network. And consider the first training cycle pair 0, 9. We know this is the input that we are going to the neural network. This should be the output. This should be the output. But we are not getting that output at all at the first point. Right? So therefore, what is the input output you will get is when IC is 0, IC is 0, W1 into 0, this is 0. Right? So you will only get B into W. So the value that you are going to get is B into W2. So it can be any number. We don't know. Based on the B and W2, there will be a number. So the error is 9. Expected value 9. But you are not getting it. So 9 minus BW2. That is the error. Right? For one point. What about the second point? You are applying 1 ampere. Now the VT is 1 into, VT should be 8.7, that I know. But what I will get is, based on the W1 value, W1 into 1 plus B into W2, this is the value that I will get based on the W1. You can add any value to this and see, right? W1, W2, BW. Then the error is 8.7 minus W1, W2 plus BW. If you go to the third point, I am applying input as 2. Expected output is 8.6, right? But if you apply 2, the value I am going to get is this one. Now the W1, the W2 is a same value. It's a one training cycle, right? So W1, W2 plus BW2. So 8.6 minus this is the error. So like that, you calculate the error for all the value. So now the error is going to be given. We calculate the error and we should say this is the total error. So we don't add those errors. Because why? There might be a plus error, there might be a minus error. So if you add plus and minus, sometimes the error, total error. If the 0 comes, AI thinks, okay, I achieve 100% accuracy. No. Right? So we cannot let that happen. So what we do is, we do the square of the error. Right? We calculate the error and square. That means the plus signs will be, minus signs will be go down. So only the plus is going to be there. So we square the error. 9 minus BW2. That is the first point when I am giving the I is equal to 0. Error is calculated. This is the second error. This is the third error. This is the fourth error. Like that, I am going to add all the error and square it. And take the square root. That means all the positive errors are going to be added and taking the square root. So let's say this is the first error is A, second error B, third error C, fourth error B, like that it's going to go. I calculated and get the square root and give it to the neural network as a back propagation. Right? So now this is the error going into the neural network. So that is a first time insight. Then similarly, the W1, W2 weights values are going to be changed, bias is going to be changed. Then the second training cycle starts. Then again the error is calculated. We give this value as a back propagation. Then the AI, they see it, okay, compared to the last error value, this time I got higher because it can go also. Because W1, W2 is going to change in mostly random manner, right? So then if we see higher and it say, okay, last time the W1, W2 are, let's say, we'll say 0.1 and 0.2. Second, the error is less than the second. Second, I'm increasing 0.2 and 0.4. The error is higher. So then the AI will understand If I increase the weight values, the error is also going high. So I should reduce the weight value. So then W1 0.01, W2 0.05. Then it see the error is reducing. So it will find the trend and change the W1, W2 values to get the error as minimum. Finally, when we feel like, okay, now this accuracy is enough for me, okay, I have run for 100 reports, so this is the error value I am getting. This error value is fine for me. Then I stop at the point and say, this is the AI model, this is the value of the internal basis. Our example, these are the total error that we have calculated, and we can do this example in form also. Adding the values W1, W2, and V and calculate the error. This is the number of iteration, 1 point, number of iteration, 20 points, number of iteration, 40 points. So you will see when these, see the number of iteration, first training, iteration, epochs, training cycle, all are same. Iteration, epochs, training cycle, all are same meaning. Okay. So number of iteration, the first training cycle, this is the weight it's assigned, and this is the B value it is getting. So when you calculate the error, definitely it will be higher. Then after 20th iteration, 20th cycle, these are the weight values, and you can calculate the error. And 40th cycle, these are the weight values, you can calculate the error. If you see this error, from that graph, we saw that green graph going down. Similarly, you will see this is higher, this is lower than this one, and this error is lower than that. So now what we do basically, we are changing the synopsis points and changing the strength of the connection. Strength of the connection. Weight is the strength of the connection. By changing the strengths of the connection, I am making a desired output. Exactly, this is what happened in the brain. Right? Exactly, this is what happening in the brain. Our neurons are interconnected. The strength is higher or lowered or something to make the correct. Now I am doing a cover drive. This part of the hand is not working properly, then it might strengthen the output or it might reduce the strength value, the brain. Same thing you are doing to get the correct output. So how the human working the human brain to make this AI, right? So that's how. Yeah.
Right. So, ask this question from ChatGPT, ask. Probably was my answer and the answer of the equation. And then you run a model, you come to near that answer by having your ChatGPT this time.
Agility is a rich architecture. There is no branch over one. So generative AI, it's called as generative AI. Right? So it generates the next one. That's all. That's all it does. So that training cycle, if I tell you, it will be confusing now. I tell how it works in a very simple manner. If I say the cat jumped and complete the sentence means, what we do is we take the as an input cat jump, the cat, okay? Then it will go and see these are the input and the output will be has a whole database training from the internet, all the text, all the textbooks, whatever the Wikipedia, those are the things training. So what will happen is it will predict the most used words in the text when the cat related. So that the cat jumped, then definitely after jump, it should be over. We also know it's over. The ChatGPT, based on the training, it knows the next wave is over. So it says over. Then what is happening? The cat jump over. Then it predicts the next one. Over, maybe the fence, wall, bed. What it will do is it will predict the next word based on the word it trained. In the past, it might have seen a lot of words. So it will predict the next word which is trained. So like the cat jumped over the fence. It will get a jumped over the fence for me. Maybe they jumped over the fence for you. I jumped over the wall for you. Because if it predict only the most available word, as an output, right? As an output, for the same answer I will get, you will get the same answer, you will get the same. What the people have done is, it predict gold, pens, and bid, share. So most 1, 2, 3, 4, 5 rank good. And external algorithm, it select one word randomly. So for me, it might say wall. For you, if you try, it will say bed. Because the words are different. So after finishing the word, and if you want to even complete the sentence or extend the sentence and complete it as a prompt, it will take the cat jumped over the wall and fill it up. So and scroll down. And say yeah. So all these things are predicted. So that's a different architecture. Now we will not go into that. It's called transformer architecture. That's what said 2017. Who identified the transformer architecture? Yeah. So this, don't think the transformer architecture is very familiar. Again, these multiplication of numbers, nothing else. Right? It's very interesting. Actually, in 2017, Google found this transformer. But OpenAI took that architecture, they developed to a next scale into a practical use. That's how the ChatGPT came. Then Microsoft took a smart decision to sponsor that OpenAI, and they became as an investor. First, they give $1 billion. After the ChatGPT pumped up, they give $10 billion. Microsoft is in top of AI business. But Google still it says, no, we are the person who identified this one. Who cares? Nobody cares. ChatGPT is working. How many of you tried Gemini? One of the funniest model, right? It's not that accurate. But accurate means not that good to use as an interactive tool to get the answer. But ChatGPT is more smart to
train for all these kind of.
yeah. Not questions. Words. Word. How it's trained on words? Because we are working with numbers. Yeah, please go. Yeah, that is the. It's still not in the market. I never used it, but I believe it can handle multiple parameters at the same time. So when you put right now, what we do is for the training process. Training process means this is multiplication of weight, multiplication of weight. Imagine you have multiple number of neurons, hidden layers, multiple number of hidden layers. What we do now is, this hidden layer all loaded into one GPU performance and multiply all the weights and give the output at the same time. So maybe the Blackwell chip will handle this whole set of things in parallel. I have no clue about it. I can check it, but it will be more faster, one thing. And the other thing will be, we can build large neural networks, which can outperform humans. Taiwan is the main place the chips are made. NVIDIA also have a branch, manufacturing branch over there. So not only in Taiwan, there are many other places also. They have sub branches, but main in Hungary. Hungary is another. These are already coming into market. Earlier, the GPU having a GPU in a machine is very costly. Now it's have a gaming laptop with RTX 5060 for 2-3 lakhs in Sri Lanka. 2-3 lakhs in Sri Lanka. Right, so very cheap. So the Blackwell is going to change the world again. And day before yesterday, I saw an interview of an OpenAI, that person who is the founder of the OpenAI, said ChatGPT 4 is the dumbest model ever you will find in the field. I think the dumbest model ever you will find in the future. You can imagine what kind of models are going to come. Right? All these video making, image making, text making, all these things are from the ChatGPT. Already the photographic competition, one AI model photo won the first prize. After he won the prize only, he said, this is not my photo, this is developed by AI. How it's in the daily so everyone will have a GPT. So you are a lawyer, you are a counselor, anything, okay, I will have a counselor GPT in my phone.
The law model that they will develop for the lawyers.
Yeah, that is again based on the ChatGPT backend. So there is some demos we will say we as a company we have developed. So these legal assistance with companies. So what they do the contract, they find out if the contract is okay in align with the company policies or national laws or those kind of things. They have to go through certain documents, spend weeks to renew that. Now we don't do that. So what we do, we upload all the company compliance policies into one document and you draft randomly whatever you feel like about the contract, copy, save and paste it over there. Now you click the button, check for them. What the AI will do is it will study the whole entire compliance document and check the relevance with the draft document. And it will say, no, there are flaws here, here, here. So you have to fix them. And it will ask, whether I should fix it or you want to fix it. Then you just click, you fix it. It will rewrite the whole thing. Within a day, we can practice out. Right? So there are multiple things you can do. HR admin, we have automated for a company called BCS Technology. So they are a kind of a human recruiting company. For the project comes, let's say one company say I need 10 people, software engineers for 3 months for this project. Can you give me? Then they hire the people and they give. So when they post a job advertisement, thousands of CVs come down. They cannot sit and reading thousands of CVs to find the best person. So we have automated this. Job description, copy, paste it in the AI model, upload all the 1,000 CVs that you got in the AI. Automatically within 10 minutes, you will get the ranking of all the CVs compared to the job description.
So you have to give the
Job description. Job description. So based on the job description, the matching CV will be found and it will be put in a CSV, like Excel file also with all the details. This is an email, this is the experience level and everything. And you can do the sorting. Okay, I need the experience more than 6 years. Okay, drag and put 6 years. I need the GPA more than 3.3. Drag and put the 3.3. I need the people less than 27 years old. Okay, 27 years old. And also, some people don't put the years in the CV. Many people don't put I'm 50 years old. Right? So what it will do is based on the experience, and model will estimate the age of the person. And it will put estimated age. Age estimated in the bracket E. So based on that, you can sort out the series. Once the sort with the series come out, based on the ranking, you click send the mail for interview. Then that platform, AI platform, sends the mail for all the selected employees out of that 1,000. All these employees will get an email. Congratulations, you have been shortlisted for the first HR interview. Click this link when you are ready to attend the interview. So when you click the come up and it's going to ask question to you, you answer and record an answer and it rate the answer whether it's correct or wrong. Finally, next day HR goes in the morning. Okay, this is the marks of these candidates.
So there is no human input.
Okay, HR just need to make the final copy. So that is already made, like I showed them. Right, so imagine how the way is done. And the other example, programmers. So there's another company in Mexico. They spend $100,000 for the code update because their platform changes something. They have to change their code also. So they have a team to do that. So when these people change, then they have to change within 3 months period. Otherwise, that will not work. This code will not work. It's an airline company. So one day down, then they will lose millions of dollars, right? So now they pay hundreds of thousands of dollars to multiple workers to manually upgrade those codes. So these people give a document, okay, these are the changes that we have made from our side. So then these people study the document and they go through and they do Therefore, test it and troubleshoot, test it and troubleshoot, and finally do it. Do you think AI cannot do it? AI will do it in half an hour. Okay? So we are working on a model to do that. So they just need to upload the document that these people are going to give us. Then the code, existing code right now, then the AI will take care of the code generation, testing, troubleshooting, finally give the output. Where you check one guy, human guy, need to check that whether it's correctly or not. Upload. Within a day, whole update, human moving one. Right? So there are a lot of things going on here. And with all these things, it is done post model GPT-4. So I can't even imagine when other models comes up, how the world is going to go. But yeah, in Sri Lanka, so we are the people, last people we will get affected. Still, we keep documents in the offices, right? Because if anything comes up, they will burn it and say, okay, it's good. Nobody will get caught. So we are the people will get affected at the last, but it's not good also. We have to be competitive. So we have to know what is happening in the world and get ready for the world. Because many software companies I have seen after the economic crisis, our labor costs become very cheap compared to India. So and during the COVID, they realized Sri Lankan talent. Until then, India was the hub of IT. Everyone went to India saying India is the talented people. But I have worked with Indians in PhD and everything. I know how they work, right? So we have like 100 times better knowledge in Sri Lanka. So it is not exposed. It is not exposed. So during the COVID time, during this online working culture, we exposed our talent to the foreign world. So now the software companies coming and starting companies here. So that means they need AI into their system. So if we know AI, we can directly get into a thing. So one of my student in ESOP, he did undergraduate project with me. He did some diploma in Katunayaka area, some college, technical college, and he did top-up degree in ESOP. So he did a small AI project. I found out he is really talented, recruited him for a company, and he worked on that company for 6 months. Now he got a company in US company. Per week he have to work 25 hours, only 25 hours per week. Can you guess his salary? Per week, 25 hours he have to work. He's earning $5,000 per month. 5,000 USD per month. He's 28 years old. So that's the power of AI, right? You know what is AI? Get some training. Now world is big. The companies are ready to hire from Sri Lanka because they know the talent, right? So these are the current trends going on in the medical world. There was a project came to us from Dubai, but due to some issues, it got delayed. Still, it's pending still. So there will be AI doctor. AI doctor. So what's the doctor do? Medical doctor do? Somebody said you are working in medical place, right? So what the doctor do? They do case study. They come. You say I have a fever. I have a pain in my chest. Based on the knowledge that they have learned in the campus, they anticipate it might be these things. And they write, okay, take this test, take this test, take this test. We take the test, go and submit the report. And all these tests are engineers made, right? So they go and read the report and say, okay, your blood sugar level is high or like that thing. Okay, these are the medications. You think the AI cannot do it? Even the ChatGPT can do that. So, but the only thing is the accuracy. The issue is if the AI give a wrong medicine by any chance, because you have seen what is the output, it's not 100% correct. It's probability. So if the AI give a wrong medicine, who is responsible? So therefore, there is a doctor who should approve. So the project was all about you go talk to a chat. I have this feeling, you have to fill out a certain questionnaire. Based on the questionnaire, it will ask certain question back to you. You just type or you talk, okay, I have this feeling, this side is a paining. And it say, okay, press your stomach and see how the pain level, okay. So this is the pain level in my this stomach or something, all these things. Okay, then it give, okay, take this test. And you go and take that test, take this as a PDF, come and upload back. and it identify the diagnosis, and if it cannot, it will prescribe for more tests. Then you go and take an upload. Finally, it will say you are diagnosed with this thing. And it will prescribe the medicine also. But the company doesn't want to do that. They say, okay, analyze and predict and give it to a doctor. The doctor come and analyze whether it's right or wrong. Only he need to do is approve or reject. Then once he approve, the answer will be shown to you. So you don't want to go to hospital. You can consult doctors in US from Sri Lanka. Right? So this is how the world is changing. So that project from Dubai, actually, it came, but it stopped at the middle. I don't know. There are certain issues. These doctors are scared. Do you think the doctor will give 100% right answer to train the AI? If their job is under scarcity, they will not. So there are issues on working with doctors and everything, but it will be sorted out soon. So only who knows AI will survive. Even I worked in an Australian company project, dentist. So now there's a like filling, that you remove the one tooth is broken. They fill it using some metal and fix the thing. It takes a month period, right? So now what do? You go there and they scan using a camera, an AI print out. Earlier you do a bite, right? Bite and it's sent to somewhere else, and the tooth come after manufacturing, maybe after a week. No, you do a camera scanning using a camera, and AI design the tooth design and everything, 3D printed. Wait for an hour, take your teeth and go home. So it's happening in Australia. It's in practice. So these are the things AI input. So ChatGPT is a small thing, tiny thing of AI. Everyone knows ChatGPT, but ChatGPT is a very small part of it. But there are many more other things. So we'll learn one by one, right? So any doubts, any question up to this thing? This is the yeah. So that is another model basically. Like one of the hotel in Dubai. Dubai is crazy about AI. So they want everything, AI into everything. So we are doing a project, which Paranos, and where they want to predict how many Coca-Cola bottles will be sold next week in my restaurant. Can you imagine, to manage the stock? They want to know how many items and which items will be sold next week in this particular day in my restaurant based on the previous history. 300 menu items are there. They want to know what menu item either for lunch or dinner or breakfast. That accuracy they want. They don't know AI. That's another thing. When we try to explain, no, we can't do that lunch, dinner thing. It's very hard. AI is not in the work. They don't understand. They will not give the project. We say, we'll do it. Give it. And we do something and we show. We know how AI works. So there are certain limitations. We cannot provide everything. So we finally made it and we finally explained, okay, this is the results if you go for mean-wise, accuracy is very less. If you go for day-wise, this is the results and this is the accuracy. And they said, then forget about meal period. Per day, how many items will be sold is enough for us. So, like that. So there are many things like going on in the world, and another thing. I'm working right now. Yesterday, I completed that project. One Australian company, they give loans for the restaurants, right? So what they do, I apply in online portal. So there are 20, 30 people working in the back end. There are like thousand applications come per day or per week sometimes. So there are all the people, they have to go to that particular address, business address, view it in the Google Street View, right? They go open the Google Street View and see the building, how it looks like. And they see the area, whether it's suitable for a commercial area purpose, and whether that investment loan is feasible for them to repay. And also they check in Facebook, LinkedIn, and other social media about the person profile, that shop profile, that area profile, everything. And they create a report whether the loan is approved or not. This takes maybe 2-3 days to analyze for a couple of 10 addresses. So now we are automating that. Once the person come, enter his name, the shop address, and requested loan amount, automatically Street View image is taken, the surrounding image is taken, put it into an AI model analyzes all the things and say this is a suitable business place or not a suitable business place. On top of that, the AI web crawlers go through the Facebook, LinkedIn, and all these things and search this guy's name and the relevant addresses of that shop and go through the customer reviews and everything and make a report. Within 10 minutes, the report is ready. So 20 people for 1 month work is done in a short time. So then what these 20 people are going to do? So that's where the AI is going to have an issue. Right? So yeah, we are destroying, but the accuracy is high. The companies like it.
But of course, the jobs will be created as well. Because some of the jobs will go. Well, we know which
Yeah.
jobs will be.
Now it will go, but it will take some time to create new jobs. We don't know what job is going to come back again. There are like when the typewriters, computer came, the typewriters had a scarcity, they will lose their job. Right? But of course they lost, but they converted to learn typewriting in computer. So then they continue, right? So that's how something will happen. But the initial first 2 years, there will be a huge job crisis is going to come. After that, they will find out how to move forward, right? But this is a new era and the way is moving very fast, very fast. If you sleep for a day, 2 days, I'm sick and you go back and look at the internet, there is a new thing released, which you have spent 2 weeks, 3 weeks to do some projects. Now you just use this model and upload, the project is done. So like, it's very fast. You have to be always updated in the field. And software engineers are going to lose job definitely. And yeah, because for example, 10 people company, a software company is having 10 software engineers, the whole software job can be done with 1 engineer. But many startups will come up. Many projects, I don't know what's going to happen. We'll see. Okay, any questions up to that? Up to this point. So now this is the value that we have calculated based on VR. So the internal resistance should be 0.21. So now you got how the AI works. Very simple. Changing the weights and calculate the error. So how many of you know this before this class? Anyone told me about AI using what is happening inside? So this AI ChatGPT is little different from here. We'll learn that also, but that is too early to this class. But now you know how the base recognition works and everything. Right? You have to go through separate base recognition, certain phones working differently. But we'll see. We'll make an door unlocking system based on the phone. Yes. What's based on the door unlocking. Right, that's all for today. So any questions, doubts? So you'll be look for an email. You'll get an email and you can set up and enroll for the class. I have experience teaching 4 hours continuously, so I don't get tired easily. So if you want a break, yeah, of course, definitely.
Next time.
Yeah, okay. Yeah, next time we'll do. 15 minutes after 1 hour. Yeah. I'm okay.
And also the, so we get the email.
Yeah. So check your mail, so you will get a one. So we can. Next lectures we need the platform because we are going to start Python coding. So very basic coding, you might feel a little boring because we are starting from if, else, loop and everything. So, but it's useful to recover your knowledge. Yeah. So after that, day by day we will do. Even this 18 lesson is a predefined lessons. But if it's in the way, if I found out some the Google API something, I will teach that much. So it's a practical real world problem. So those things we will on the go we will decide which lesson we will teach. Right? Okay. No, this is fixed. You will learn all these things on top of this answer. Right? So I'm not going to change the plan, but the practical examples we will get it on the go.
You can.
Yeah.
we call it use cases. Where your organization has certain things that you think that AI can be applied, you come and discuss here. So that you have a certain amount of data, and then how do you apply the model that can be discussed in the class. I think we better.
Yeah.
You bring your use, we call it use cases.
So the dialog company came to me. They have an issue on monitoring these customer care representatives. So they are calling. Not everyone is go and answer the call rating. So they want to automate it. So now we are implementing a model. When you talk in Sinhala, Tamil, English, it doesn't matter. So your response and the customer care agent response will be recorded and it will be ranked. He should have told this, but he told this. So this is his marks. So at the end of the month, the representative is going to get a mark. So now everyone is on Daniel. Based on the marks, they are going to promote or depromote. So we are working on a model, still not established. So those things are there. So they are POCs. And also they want a model to train the customer. So we created an AI customer. So the AI customer come and chat. Yeah, I'm a customer care agent. I'm going to get the training. So we created an AI customer for dialogue. So we got all the issues that the dialogue faced, fed it into the AI customer agent. The customer come and say, hey, I have an internet issue. So then as an agent, I have to reply back. Then I reply back and the AI model evaluate the answer and say, good, you have responded very nicely. However, you can improve your answer by saying this. So then I read that, then I know, okay, this is the answer I should say. So that is another tool that we are developing. So there are limitless opportunities. So if you learn this course, you will find out. All right. Okay, so that's all. Thank you for joining. See you next week then. Until then,
We have
bye.
got very light discussion.